Greetings everyone. Today we're going to explore graphing and writing equations of circles. We do have a specific foldable for this conics unit, so make sure you have it available. Quick review of the parts of a circle that we're going to need today. Specifically, we're going to use the radius, which we have used in many equations previously, and the center. The difference today is we're going to have the center as a coordinate point on a graph. The standard form of the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. Now, as we've used before, we're going to have the opposite sign as part of the formula. So if I say that the center is at 2, 3, we actually write subtract 2 and subtract 3. You'll also notice the radius is always squared as the solution. Now, when it comes to equations of a circle, unfortunately your physical graphing calculator isn't much help unless you have the program. Something to consider if you're very comfortable with your calculator. But you can also use Desmos and other resources to help you understand. So let's work on the basics of graphing a circle. So the first thing I want to identify is my center point. If it says x plus 2, I write negative 2. If it says y plus 3, I write negative 3. Just take a moment to notice how we have this x quantity squared and this y quantity squared. As we dive deeper into the conics unit, the layout is really going to be important. My radius, however, this is normally r squared, so my radius is 6. So let's plot our dot negative 2, 3. We want a radius of 6, so the easiest way to do this on a coordinate graph is just to go 6 in each direction. So I'm going to go 6 east, I'm going to go 6 north, 6 west, and 6 south. Now, you are going to have graphs that go, points that do go off the graph throughout this unit. That's okay, just make some assumptions. And I'm using a tablet, so of course my circle's not going to look the best. My hope is, since yours is on paper, it looks better than mine. If you still happen to have a compass from geometry class, that'd be a great resource. Let's take a look at this one. Just a reminder that if I'm not adding anything to a value, that would represent a 0. If it says y minus 1, my y is positive 1. So I've got my center point. This is normally r squared as part of the formula, so we have a radius of 8. So we want to go 8 in each direction, which makes it a pretty wide circle, which to be honest makes it a little harder to graph. Okay, so make sure again you have paper, make sure it's much better than this horrible tablet writing. Let's try one more. If it says x minus 4, I'm at positive 4. If it says y plus 7, I'm at negative 7. Normally the radius squared is the solution, so my radius is 3. So let's go right 4, down 7, there's my center point, 3 in each direction. Nice small circle, a little bit easier to graph. Not too bad. Let's jump to writing though. This is towards the back of your foldable, so I'll give you a second if you need to pause and find that spot. This example in your foldable is labeled number 11. So I always like to start with the general layout, right? An x quantity plus, that plus matters, circles are addition in the middle, y squared equals r squared. So just remembering that layout. So my center point, I have to find it is 1, 2, 3, 4, 5 on the x. So that would be a minus 5, and I go up 1, so my y would be minus 1. Now my radius, if I count it, it's 1, 2, 3, 4 in each direction. So if I square my radius, I will have my final equation. X minus 5 quantity squared plus y minus 1 quantity squared equals 16. Now you always want to simplify that radius squared. Let's talk about from information. Let's set it up first. It's going to be x quantity squared plus y quantity squared equals, and remember this is going to be radius squared. If my x is positive 9, I write minus 9. If my y is minus 4, I write positive 4. And let's talk about this radius squared. That's why we worked on exponents and radicals in the previous unit. I square each piece. 2 squared. The square root of 7 squared is inverse operations, which eliminates the radical. If numbers are next to each other, that implies multiplication. So I have a 4 times 7 for a solution of 28. You do have to simplify it all the way down. Now things get a little bit tougher. I can get going with my center point, so I'm going to write a little lower here. X quantity squared plus y quantity squared equals. So I can easily see my x is minus 1, so I write positive 1. My y is positive 7, I write minus 7. But I have a point on a circle, so I need to find the radius. So let's do a little sketch here just to imagine. Negative 1, 7, we're dealing with the top 2 quadrants. Negative 1, positive 7. So that would be like here, right? Here's where your marker board would be helpful too, to draw a little sketch. And then if I'm going from over to 9 and up to 10. Okay, so if I take a look here, I need to find the distance from that center point to the point on the edge of the circle. Let's go back to geometry. We're going to review. I can create a right triangle. This is a slanted length, so I can't just count it, right? I have to do a little bit of work. This creates a right triangle. So here's where your graph paper or your marker board would be so helpful. The horizontal distance, the length between the x values is 10, right? Negative 1 to 9. The vertical value between 7 to 10 is 3. And my goal is to find out what the hypotenuse is. Take a moment. If you need to pause, think about that. How do we find that hypotenuse length again? That's right. We need to use the Pythagorean theorem. The Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. And my hypotenuse is my r. Let's calculate. 3 squared, 9. 10 squared, 100. I end up with 109. And believe it or not, I don't need to do any extra work. Oops, let me fill in some of those blanks there. Because this is what r squared equals. And that's what the solution is supposed to be, r squared. So it's a little less work because I don't need to solve exactly for r. I want to solve for r squared. All right, let's talk about this next one, number 14. Now, I was stressing using your marker board, but in this case, you can see that one of our points is negative 17, which is greatly off the marker board, right? So I'm going to encourage a generic sketch. Now I'm going to be using the second and the third quadrant. I've got negative 4, 7, and I have negative 8, negative 17. Now let's talk about what those points represent. They are endpoints of the diameter, meaning if I connect them, right, they are the length of the circle when going through the center point. So I don't even know what the center point is. So let's refresh our geometry brains. We need to find the midpoint. the midpoint, the middle of those 2 points. Well, let's talk about midpoint. It's a point. If we're finding the middle between two values, we're finding the average of 2 x's and the average of 2 y's. Okay, so let's calculate that. X plus x, so -8 plus -4, we're going to cut that in half. The y's are 7 plus -17, and we're going to cut that in half. And here's the thing, if you've got a little sketch, it's going to make sense, right? So let's calculate this. A -12 divided by 2 would be -6. This would be a -10 divided by 2, which would be -5. So does that make sense for my middle value? Yeah, it does, right? Don't leave something that doesn't make sense. So I have my my center point. If it's -6, I write +6. I forgot my plus sign. If it says y -5, I write +5, quantity squared. Now I need to find the length of the radius. I have that middle point, so let's create a right triangle so we can do Pythagorean theorem. The distance between the y's from -17 to -5 would be -12. The distance from -8 to -6 would be -2. So let's calculate. 12 squared, the negatives are relevant, it would become positive anyways. 2 squared equals r squared. 144 plus 4 equals r squared. So my final solution is 148. Now, can you do this without the visual? Yes, if you're able to comprehend that information, but I encourage you as a form of work to leave a sketch on your paper so I can see how that's going. All right, that's our quick lesson for circles today. Conics does get much tougher. This is an introduction. Circles are the easiest part of this, so make sure you check up on any videos you need to. Make sure you check out Google Classroom to see what the task is at hand. And until next time, have a good one.